everyone. Welcome to the next exciting installment of Chapter 12. But before we get going, let me just remind you what we covered the last time. So we learned a lot about the correlation coefficient, which is the R value. And that R value is used to describe the relationship between two or more numerical variables. And just at a glance, the R value tells us two things, right? The size of the R value, how large the number is, tells us how strong the relationship is. And the sign of the R value, whether it's positive or negative, tells us the direction of the relationship. So we learned, of course, a lot more than just that. And so I encourage you to go back and review if necessary. Also, be sure to read your book, because the more ways you engage your mind, whether it's, reading, watching, listening, writing, engage all those aspects, that will actually help to solidify the material and get you to think about it in different ways. All right, so where I want to pick up now is a few things about the correlation coefficient that are important to note. And we also need to cover something called the coefficient of determination, which is R squared. After that, we're going to move ahead to regression. All right, so let's get going. As far as correlation is concerned, like any other test statistic, it can be significant or not significant. We have a way of determining that. And of course, if you're using SPSS, it's really easy because SPSS will tell you. It'll give you the sig value for your R. All right. Now, if the sig value is less than 0.05, then your R value is significant. And it means that what you're looking at is probably not unique to the sample. What you're looking at is probably a real relationship in the population. And of course, if R is not significant, in other words, the sig value is 0.05 or greater, then that's telling you that whatever relationship you think you're seeing, that is only unique to your sample. All right. So if you did go out and test the whole population, that relationship would probably not be there. So obviously we're hoping for statistically significant results. But here's the thing. Just because your results are significant does not mean that they are important. All right? And we tend to forget things like that. We think that just because something is significant, we should all rush out and, go to the top of a mountain and yell out to the world how wonderful and important our results are. But that's not always the case. If you have a huge sample size, that very often will lead to significant R values. But if you look at the actual size of the R value, it can be pretty small. All right. And so that is the word of caution or word of warning I want to leave you with. Because your R value is significant does not make it important or meaningful. Right? Look at the size of the R value and see if really, that R value is meaningful, because it's not always going to be. Right. So because a correlation is significant does not mean it is important.